5-1 and 5-2, the good news is they're pretty similar. The bad news is they're pretty similar. If you hate one, you're going to hate the other one as well. Okay? I actually think 5-2 is a little bit easier than 5-1 because it gives you an end goal and it's easier to figure things out when you know where you're going. Okay? But everything you need to know, both of those sections, is on this one screen. These are all your fundamental trig identities. This is never going to be given to you. You need to know everything on this slide. Most of what's on this slide we've already talked about. You know your reciprocal identities, or I should say you should know your reciprocal identities. Okay, secant and 1 over sine are the same thing, which means the reverse of that, 1 over cosecant, is the same thing as sine. Secant is the same thing as 1 over cosine, and the reverse of that, 1 over secant, is cosine. And then cotangent actually has 2 options. You can either say that cotangent is 1 over tangent like this one, or you can replace it with cosine over sine. And then tangent also has 2 options. This one, which is sine over cosine, and 1 over cotangent. So those are both tangent. And all this means is you can replace one with the other, okay? We get into Pythagorean identities, which is the next one, and I'll go back to that in a second. These are what happens if I take the ratios of my triangle and I square them. If I square sine squared and add it to cosine squared, I always get 1. If I square tangent squared and add it to 1, I will get secant squared. If I square cotangent squared and add it to 1, I get cosecant squared. The next ones are even and odd identities. And again, we've talked about these: sine and tangent and their reciprocal functions, which is cosecant and cotangent. These are called odd functions, which means if I make the angle negative, then the function itself becomes negative. So a cosecant of negative x is the same thing as negative cosecant of x. And the cotangent of negative x is the same thing as negative cotangent x. All right, so those are your odd functions. And then the even ones are cosine and its reciprocal function, which would be secant. And even means that even though you change the sign on the angle, it does not change the sign on the trig function. And that happens because if you think about your positive and negative angles, these fall first and fourth quadrant would match, and second and third quadrant would match. And for sine and tangent, if I go from first to fourth, my sign changes. If I go from second to third, my sign changes. But with cosine, if I go from first to fourth, it stays positive. And if I go from second to third, it stays positive. So most of these you're not doing with values anymore like we did the first time around. You're doing them with replacement. So if I saw something like cosine negative x, I can immediately replace it with cosine of x. If I saw something like tangent negative x, I would immediately replace that with negative tangent of x. That's how you'll use these. And then the last one, the cofunctions identities, which we also talked about in last chapter. Every function has a match that would go with its complement. So the sine of pi over 2 minus theta, or u in this case, is the cosine of theta. Sine and cosine go together. Tangent and cotangent go together. And secant and cosecant go together. So you'll see this like once or twice with actual values in which you'll set up a triangle, but the rest of the time you're using it, again, as replacement. So if I saw cotangent of pi over 2 minus u, I would immediately replace that with tangent of u. Okay, so most of this stuff you know. Again, I would say that the only thing that's on this screen is new is the Pythagorean identities. And if you can, I'll show you a trick. So if you can just remember the sine squared plus cosine squared equals 1, I'll show you how to derive the other ones, okay? So if I take that first one and I divide all of them by cosine squared, what is sine squared over cosine squared? Tangent squared. What is cosine divided by cosine? And what is 1 over cosine? So notice that that is your second identity. If I start again with sine squared and cosine squared, and this time divide by sine, what's sine divided by sine? What's cosine divided by sine? And what's 1 divided by sine? cosecant. And that's the third one. So you can either memorize them, okay? It might be easy to memorize them. Tangent goes with secant and cotangent goes with cosecant. Those are the both C's go together. And sine and cosine are the only ones that both of them are on the same side. Everything else has a 1 plus the first one equals the second one. But if you forget, you can always derive them like that. So divide them all by cosine, you get one of them. Divide them all by sine, and you get the other one. For me, anytime I see something that is squared, as long as it's not by itself, I'm going to look for my Pythagorean identities, okay? The rest of them, if you have a negative on the angle, you're looking at your even and odd. If you have a pi over 2 minus an angle, you're looking at your cofunctions. And the rest of them, honestly, are just your reciprocal functions. All right, so the first example is just setting up your triangle using identities, right? So it says use the given values to find the values of the 6 trig functions. So sine of pi over 2 minus theta is 12 over 13, and then this actually should be, you're missing an x. This should be sine of x equals negative 5 over 13. So what's the equivalent of sine of pi over 2 minus x? So rewrite that. Cosine of x equals 12 over 13. I already found one of my trig functions, and then it gives me the second one, sine of x, right? Now set up your triangle. So x goes in the corner, cosine is 12, which is adjacent, over 13, which is hypotenuse. Sine is negative 5 over 13, so I know that side is 5, but what this is telling me is it's now what? Negative 5. Now I already have sine, I already have cosine, I just need tangent, which is opposite over hypotenuse. Opposite over adjacent. And then I need cosecant. Flip the sine, negative 13 over 5. Secant, flip the cosine, 13 over 12. Cotangent, negative 12 over 5. So as long as you have 6 by the end, 1, 2, 3, 4, 5, 6 functions, you've got them all.
How did you get cosine of x from the
sine of pi over 2 minus x is a cofunction for cosine of x. Then we switch to stuff like this. So there's no longer values involved. This says simplify the given expression of cosine of x times secant of x minus cosine of x. What do you normally do when you've got something in the front of your parentheses? Distribute it. So I'm going to multiply this times both cosine of x, secant of x, minus cosine of x times cosine of x. Now I want to see what I can replace. Normally you're going to leave sine and cosine the way that they are, unless they're squared. It's the other stuff you're going to mess with. So secant can be rewritten as what? 1 over cosine. And when you multiply the trig functions, so cosine times cosine is going to be cosine squared x. The squared goes on the function, not on the x. What is cosine times 1 over cosine? 1. These are going to cancel. I get 1 minus cosine squared x. And then hopefully a little flag goes off in your head that says that is a squared, and it's combination with 1. Go back to your Pythagorean identities, and there's one that said sine squared plus cosine squared equals 1. So if I move the cosine on the sine on the side with the 1, what can I replace 1 minus cosine with? Sine squared. Okay, be careful. You can't do that with 1 minus cosine that is not squared. Okay, if it just said 1 minus cosine, you can't replace that with sine squared. Does that make sense? And a lot of people make that mistake. If it said 1 minus sine of x, you cannot replace that with cosine of x. It has to be squared for it to work. All right, this one says factor the trig expression. So I want to factor this like we normally factor. What's in here now is a sine, okay, which kind of can throw you. If you want to replace, if I took sine out and I said that a equals sine of x, and so everywhere there's a sign, I'm going to replace it with a variable like a. This would be a squared, so this would be 3a squared minus this would be a minus 2, and then hopefully we know how to factor that, right? This would be 3a and a, and then negative 2, positive 1. That gives me the negative 6a plus 1a, which is negative 5a. So once I know that my order is right, I just have to take and plug back in the sign of x in place of my a. So for right now, we're leaving this. Eventually in section 3, we'll go on and solve that, but for right now, you're leaving it. And be prepared for difference of 2 squares, things like this where you've got something in front of your x squared term. You can have 4 terms where you're factoring by grouping. God bless you. Questions on that one? All right, this one says perform the multiplication and use the fundamental identities to simplify. So now it wants you to multiply. Do I distribute that squared? Does this become sine squared x plus cosine squared x? No, I have to expand it and FOIL it, right? So this would be sine of x plus cosine of x. And then FOIL it out. Sine times sine is sine squared x plus sine times cosine, sine x. Cosine x plus cosine x. Okay, so I'm here by expanding. What can I do with this? Combine like terms. So sine cosine is the same thing as cosine sine, right? The order doesn't matter, that's multiplication. So I could say that this is sine squared x plus 2 sine x cosine x plus cosine squared x. Now what? Good. So what is sine squared x plus cosine squared x? This plus this is 1, right? So I can say 1 plus 2 sine of x cosine of x. Is there a reciprocal function there that I could replace? No. Can't cancel anything out, which means that this is going to stay exactly how it is. Sometimes you'll have a single term. Sometimes you have more than one term, okay? Usually you're not going to have something like squared if there's 2 terms, because that means there's probably a Pythagorean identity in there. Unless it was something like sine squared by itself, you would not replace that with 1 minus cosine squared. You would leave it as sine squared. All right, you try these. All right, so if you look at A, it says cotangent of theta times secant of theta. What can I do here? So what would cotangent be? You can do cosine times sine, or, God bless you, or 1 over tangent, but I would only do that if there's another tangent involved there, right? So it makes more sense to do cosine theta over sine theta. And then secant becomes what? 1 over cosine of theta, and then cancel through the cosines, 1 over sine of theta. Do you leave it like that? No, I can rewrite that as its reciprocal function, which is what? Cosecant theta. Sometimes they are that easy, okay? I would say the biggest piece of advice I could give you of these is to never stop from the beginning. Always at least try them, because you might find that the last one's the easiest one. It might just click. All right, B says 1 minus sine squared over cosecant squared x minus 1. So I know that sine squared plus cosine squared is 1. I know that tangent squared plus 1 equals equals secant squared. And I know that 1 plus cotangent squared equals cosecant squared. So as soon as first of all, I would probably recommend that you write that on your test. As soon as you get it, write your 3 identities out, okay? And then as soon as I see the squareds and the 1s, I know that I'm using something like that. So 1 minus sine squared means that I move the sine squared to the other side, which means that can get replaced with what? Cosine squared. And then cosecant minus 1 means that you subtracted the 1 from the other side, which means cosecant squared minus 1 is what? Cotangent squared. And then what can you do? 2. Okay, so cosine squared in the top, and then cosine squared x over sine squared x. And then change, flip. My cosines cancel, and I'm left with sine squared x. There's always, usually anyways, more than one way to do this. The other thing that you can do is that when you have a trig function by itself or being multiplied by another trig function in a fraction, you can't do it if you're adding or subtracting, but you can simply move it from the top to the bottom by making it its reciprocal function. So if I move cotangent to the top and I make it its reciprocal function, this becomes tangent squared times cosine squared x. Tangent is sine squared x over cosine squared x times cosine squared x. And then my cosines cancel and I get sine squared x. So two different ways to do it. Both of them are probably about the same level of difficulty. Sometimes that will save you a bunch of steps. Keep that in mind because usually that's a pretty helpful trick. If the function is in it by itself, so I can't take this and move it there because it's got a -1. That's a package deal, right? I can't do that. But once I get it down to a single function, or if there was two being multiplied together, I can move them individually or both of them by just making them the reciprocal function. Okay, last one. Rewrite the expression so that it is not in fraction form. So it's already telling you from the beginning, no fraction as an answer, okay? So I get sine squared y over 1 minus cosine y. Is there something I can make 1 minus cosine y? No, it's not squared, so ignore it. What can I do with sine squared y? 1 minus cosine squared y. Now I already know I got to go further because it told me no fractions, right? So what's true about 1 and cosine squared? Are they both perfect squares? Is there a minus between them? What is that? Difference of two squares. So this becomes 1 minus cosine y and 1 plus cosine y over 1 minus cosine y. These cancel and I get 1 plus cosine y. Do not, and I repeat, do not do this. You can't do that, right? You can't cross through part of an expression. You have to factor that and cancel it completely. You cannot do parts of it like that. At least somebody's going to do something like that. Don't do it, okay? So if you see squares, remember if it's 1, it's already a perfect square. That can be factored. Yep. Yeah, sure. Like you can multiply both the top and the bottom by 1 plus cosine y. If you don't see the factoring, just makes it a little bit more complicated, but you get the same answer. There is usually one, like very rarely you find one where there's only one way to do it. It just depends on how quickly or how complicated you make it. Questions? All right, so the homework's open. You've got the rest of the time to work on it. If you don't, you're going to hate me tonight. I mean, not that I really care, but you're going to be mad at me because it's long. So you have 20 minutes. I would get a head start on it. Make sure you're showing your work with these. There are some that are obvious, and like if it just said cosine negative y, then I can write cosine of y. That's fine. I don't need work. But most of them require some work. You need to make sure you're showing it on your PDF.